If this footage came from another planet, nobody would question it. No cities, no sunlight, no sky. Just darkness, pressure, and creatures that look like they were designed by something that never saw land. But this is not alien footage. This is Earth. And the most disturbing part is that almost all of it is still unknown. The ocean is not one world. It is layers of worlds stacked on top of each other. At the surface, we see waves, storms, ships, and sunlight. But below that, the light begins to disappear. Colors vanish. Sound changes. Temperature drops. Pressure climbs. And somewhere beneath the last trace of blue, life stops looking familiar. For most of human history, we imagined the deep ocean as an empty desert. Too cold, too dark, too much pressure. A place where life could not really build anything complex. Then, cameras went down there. Remotely operated vehicles started filming the seafloor, the water column, the canyons, the vents, and the animals waiting in the dark. What came back did not look empty. It looked occupied. The first thing the deep teaches you is that survival does not care what looks normal. In the black water, beauty can look like a warning. A jellyfish from the genus Atolla drifts through the water column at hundreds of meters below the surface, surrounded by marine snow. The particles around it are not just dirt. They are the slow fall of life from above. Dead plankton, waste, tiny fragments. Every piece of the upper ocean becoming food for the world beneath it. This creature does not need a reef. It does not need a coastline. It lives inside the planet's largest habitat, the water column. That open water between surface and seafloor makes up almost all of the livable space on Earth, and yet it remains one of the least explored environments we have. Look at the way it moves. No rush, no panic. It is not swimming through an environment. It is suspended inside it, pulsing just enough to stay alive in a place where wasting energy can kill. The deep ocean rewards patience. It rewards stillness. It rewards bodies that can wait. Then something stranger appears. A glass squid passes through the camera view like a living piece of transparent machinery. In the upper world, hiding usually means matching the background. Down here, there may be no background. Predators and prey can look from below, from above, from every angle. So some animals solve the problem by becoming almost invisible. Glass squid are part of a deepwater strategy that feels impossible when you first see it. Remove the obvious outline, hide the organs, scatter the light, and become a ghost in 3 dimensions. Earth is called the blue planet because of water, but most of that water is not the ocean we know. It is this, open, dark, vertical space where animals do not live on a surface. They live in volume. They rise and fall through blackness. They meet each other in the middle of nowhere. And then, on the seafloor, the rules change again. The Schaefer's anglerfish looks like something from a nightmare because it solves the deep ocean differently. It does not glide. It does not float like a ghost. It waits on the bottom with modified fins that can act like feet. That detail matters.
In shallow water, a fish with fins is usually built for motion. In the deep, motion is expensive. The seafloor is huge, food is rare, and a bad chase may cost more energy than it gives back. So this animal becomes an ambush machine, part fish, part trap, part creature that looks almost unfinished until you realize the design is perfect for where it lives. This is what the deep does again and again. It takes a familiar category, then bends it until the category barely works. Fish that walk, squid that vanish, jellyfish that float through snow in total darkness. And the deeper the cameras go, the less Earth feels like Earth. At around 2,000 meters, the bigfin squid appears. This is one of the most unreal animals ever filmed. The body seems small compared to the arms. The fins spread like wings. The limbs hang downward in long, thin lines, creating a silhouette that looks almost too strange to be biological. Bigfin squid have been seen so rarely that every clear sighting matters. They are widely distributed in the deep ocean, yet confirmed encounters are still uncommonly rare. That combination is what makes them unsettling. It suggests the animal is not necessarily rare in the way we understand rarity. It may simply live in a world we almost never enter. There is a difference between something being rare and something being hidden from us. The deep ocean is full of that difference. For a few seconds, the bigfin squid becomes visible in the lights. Then it returns to a darkness larger than any camera beam. We see enough to know it exists, not enough to understand its life. That is the pattern of the deep. Evidence without comfort. But not everything down there looks like a monster. Some animals look almost delicate. A Dumbo octopus moves through the water with ear-like fins, using them as its primary weight to swim. It does not explode forward like the octopuses people imagine from reefs and tide pools. It glides, soft and controlled, like a living umbrella drifting through cold water. The nickname sounds almost cute, Dumbo octopus. But the environment is not cute. This animal was filmed hundreds of meters down, in water where sunlight never reaches, where pressure would crush human lungs, where the cold is constant and the world is mostly black. That contrast is what makes the deep ocean powerful on camera. The creatures can look gentle, even beautiful, but the setting is brutal. Every soft movement is happening inside a system that punishes weakness. And then, hidden in coral, there is a future predator still inside an egg case. An embryonic cat shark clings to the deep reef, already shaped like the hunter it will become. Some sharks are oviparous, meaning they lay eggs outside the mother's body. There is no warm nursery, no protection from a parent circling nearby. Just a case attached to life in the dark, and inside it, the next generation developing on its own stored yolk.
The Greenland shark does not need to look fast to be intimidating. It moves with the slow authority of something that belongs in cold water and deep time. When a remotely operated vehicle filmed one off the coast of New England, the shark appeared during the last minutes of a dive, at a depth of hundreds of meters. There is something different about seeing a large shark in deep water. Near the surface, sharks feel like predators entering our world. Down here, the feeling reverses. The machine is the intruder. The lights are the disturbance. The animal is at home. The deeper you go, the more human technology looks temporary. Cables, thrusters,
white lights, metal arms, a camera pushing into a world that does not need us. And then there are the fish of the deep, filmed across remote, protected areas of the Pacific at depths ranging from hundreds of meters to nearly 6,000 meters. They come in shapes that feel improvised. Long bodies, wide eyes, strange mouths, pale skin, dark skin, bodies built for pressure, darkness, and scarcity. Scientists do not film them just because they are strange. They film them because these animals tell us whether ecosystems are healthy, connected, changing, or under pressure. A fish in the deep is not just a fish. It is data from a world we barely sample. Every second of footage matters because the deep is hard to reach, expensive to study, and enormous. Then the camera reaches one of the most important places on the planet, a hydrothermal vent. For a long time, people believed complex life needed sunlight at the foundation. Plants use sunlight. Animals eat plants or eat animals that ate plants. Sunlight drives the system. But hydrothermal vents change that story. Here, superheated, mineral-rich water rises from the seafloor. The scene looks like smoke, but it is chemistry pouring into the ocean. Around vents, life can gather without sunlight, supported by microbes that use chemical energy instead. This matters far beyond Earth. If life can survive here, in darkness, under pressure, powered by chemistry, then the search for life elsewhere changes. Suddenly, an icy moon with an ocean beneath its surface becomes more interesting. A dark sea under a frozen shell is no longer just a dead place. It might have vents. It might have chemistry. It might have time. That is why deep-sea footage feels alien. Not because it is fake, because it shows us the kind of life we might actually find somewhere else. The final creature in this journey is not the biggest, not the scariest, and not the strangest. It is a deep-sea snailfish, filmed over 1,000 meters down during an Alaska expedition. Snailfish can look soft, almost delicate, but that softness is misleading. In the deep, bodies do not need to fight gravity the same way land animals do. They need to handle pressure, cold, darkness, and food scarcity. A body that looks fragile to us may be perfectly engineered for a world we cannot survive for a second without a machine. That is the mistake humans make with the deep ocean. We judge it from the surface. We call animals ugly because they do not match shallow water beauty. We call them monsters because their designs make us uncomfortable. We call the deep empty because we do not see it often enough. But the deep is not empty. It is older than our cities, larger than our nations, and more alien than most science fiction.
We have mapped other worlds from orbit, but much of our own ocean remains mysterious. Every dive is a reminder that Earth still has rooms we have not entered, animals we have not named, and behaviors we have never filmed. So the next time someone asks what alien life might look like, maybe the honest answer is this. It might drift like a jellyfish through black snow. It might walk like an anglerfish across the seafloor. It might hang in the dark like a bigfin squid, half seen and barely understood. It might hatch from a case in cold coral. And it might already be here, beneath us, waiting, in the dark.